about when you're given a property and you need to determine whether it is a physical property or a chemical property. So first, let's talk about how to describe something, right? So for example, the easy thing every day we do this is we describe a person. So when you tell somebody how's this person like, right? So usually you do from two perspectives. So what does this guy look like, and what kind of personality does he have, right? So what is this guy made of, basically? His look, his height, his weight, and also is he a nice person? Does he like to do this and that? And so the first part of what does he look like, if we referring back to a matter, is really talking about what's the composition of this molecule, of this chemical, right? Is it made of how many metal parts? How many does it have sulfur? Because later we're talking about for each element belong to each group, whether it's alkali metal, whether it's halogens, whether it's noble gases, they have different properties. So it's really important we know what composition they have. And the second part, like the personality, we need to know what property does this molecule have, how does it behave under different conditions. And this is super important to material science or any other uh, material related sciences, because we really need to understand about these things before we can use them and apply it properly. So, so for different properties, we can basically divide it into physical properties and chemical properties. Later lecture, I also talk about the difference between intensive property and extensive property, but that's another thing. So for physical property, sometimes people get confused, but the difference is really simple. Physical property, it does not involve a change in matter. Whatever this thing was, is still is still the same thing. So, for example, uh, when it's cold, water changes to ice, right? But it's still water molecule. It doesn't change. It's a physical change. Is just change from one state into another one, right? It become more compact, but it's still water. Also, when we describe the length of something, it does not involve the change of it. We are really just measuring the length of this thing. It's the property of it, or what temperature it have. Although under different temperatures, things may behave differently. However, as long as they stay the same thing, let's say if this is mercury inside and mercury expand under a certain heat, but it's still mercury, it doesn't change to another molecule, so it'll be the same as physical property. On the other hand, for chemical properties, also there's another example. So for density, color, pressure, this thing does not change, right? But for chemical properties, things do change. When you see something change, it becomes a chemical property. So for example, when we're lighting something up, right? Where something is burning and it's reacting with oxygen over there in the air. So things change. For example, when you burn wood, which is made of carbon, and when it react with oxygen, you can have carbon dioxide, right? Which is the main problem, one of the main player in the greenhouse effect. Or you can have carbon monoxide, which can be very toxic. Um, and carbon monoxide, CO, is actually when those kind of old movies, people, when they lock themselves in a garage and they turn on their car, and the car exhaust is mostly made of CO. And when the CO, when carbon monoxide go into your bloodstream, your blood cannot bring oxygen to your lung anymore. That's why people suffocate. But that's just for you to know. So also, in different kind of chemical experiment, when you mix something with another chemical, the color change. So this usually indicate a chemical property, because a color change is usually related to a change in chemicals. So there will be this, because there's a change in the matter. you have a chemical property here. And also another thing that you might not be aware of is radioactive materials. You probably heard of the term half-life, which is referring to the time for half of the material to decay. And because this radioactivity, there is actually a change in matter. Sometimes is isotopes uh, for a molecule or for a atom, it'll lose its neutrons, its electrons, but there is this change over there. So as long as there's a change, it becomes a chemical property. So now let's do some questions just for practice. And this is a very important concept that at the intro level, people always test on this because it's just such an easy question to make up about. So first one, this is a physical property or is a chemical property that the glow sticks can give a light in dark? Well, it's usually it does not shine, but sometimes when you bend it, it becomes a start to glow, right? So it'll be a chemical property because there is a change. So the way usually glow sticks work is that it has a dye, and then on the other side, it has a some kind of exciter. So when you bend it, it breaks the boundaries, the barriers between them, so they start to mix. And then when the exciter hits react with the dye, it brings the dye into another energy level. And then when the dye going to come back to it and to give out energy to come back to its original state, and this give energy that's being given out is the light we see. For another example, we know mirror can reflect light, and usually that's done by we have a very thin layer of aluminum over the glass. So is this a physical property or chemical property? Well, there's no change for the glass, it simply reflects light, so it'll be a physical property. Uh, and I like eggs, and then we know that when we boil it, it turns from its original state into this kind of state where we can eat. Um, and then does it is it a chemical property or is it a physical property? Well, the thing is, the egg are full of enzymes and which are organic molecules. When we heat them, they degrade, they change, and they denature will be the correct term. So they change their chemical composition. That's why, because of this change, it will be a chemical property. And for the last practice, we know that on rainy days, after the rain, the water are still absorbed onto the glass and they wouldn't come off until they're being heated by the sun and evaporate, right? So this absorption process is a physical property, right? Because there's no change, water simply sticks on it, and just because their physical in intermolecular attraction force, right? So there's no chemical change, so it'll be a physical property. So I hope you understand the difference between physical property and chemical property by now. In the next video, I'll talk about the difference between a physical change and the chemical change, which is really similar to this, but just for your understanding, because they always like to test on this. See you in the next one.